from Israel, and I go way back, like 30 years of experience. I started in the Israeli army in computers and did lots and lots and lots of stuff, mostly programming. It's about a hackathon I did at Wix. Wix, we have a yearly hackathon, and in that hackathon, we decided to build a microservices infrastructure for Wix. Good noon, everybody. My name is Gil. You've heard about me. I've been in a theater, but I've never been in a cinema. So this is the first, and we've got advertising for me, which is fun. Okay. How to build a microservices infrastructure in 7 days. This is my Twitter handle. Feel free to tweet after or during. So as I said, Wix has a yearly hackathon in which people do basically whatever they want during 1 week. It's every year. It's a nice thing. And I was thinking to myself, what to do. First of all, this is the. I like my presentations to be themed, so I thought to do a movie script. I heard there was a film festival here in Vilnius, so it works. So prologue, what is Wix? Everybody, well, not all of you know about Wix. Wix has 100 million users. What they do is they enable you to build websites. They enable you to build websites. You can do it for free. You get a little ad on the top, or you can pay premium and get a really nice website with no ads. It's huge, 2 billion requests per day, and it's a microservices infrastructure. And I'm not going to talk about what are microservices, because there have been lots and lots of talks over the past 2 years. I'm assuming you know what microservices are. If you don't, you will get the hang of it during my talk. And 200 microservices at Wix, probably 300 by now. And we have 100 deployments. I don't work at Wix anymore. We had 100 deployments per day. So we do Agile. We have a full CI/CD pipeline, and we do changes. We write the tests. We deploy the backend, and your feature is in. It's that simple, and we do hundreds of those per day. Unfortunately, we're doing it on an aging microservices infrastructure. The microservices infrastructure was built at Wix on the days where there was no Kubernetes, no Mesos, no Marathon, no thing. We had to build it homegrown. There was no other option. First of all, what is a microservices infrastructure? Let's say we have 3 microservices, or 4 in this case, A, B, C, and D. And we need to run those microservices on servers, because that's what microservices do. They run on servers. So we need to deploy and run those microservices on a cluster of somewhat the same servers. We need to deploy them. And as I said, we have hundreds of those every day, hundreds of deployments of versions of microservices. So that needs to be fast. We need to make them run, obviously. And we need to keep them healthy. So if a server falls, somebody else picks up the load, or if a microservice falls, somebody else picks up the load and brings it back up. And why is the microservice infrastructure bad at Wix? Well, it's not bad. It works. But it's not good enough. Well, first of all, the deployments, remember, hundreds of them, are very slow. And why is that? It's Chef-based. And Chef is not optimal for doing deployments. I did deployments using Chef twice during my career. Don't, please, never. I mean, it's the worst tool. Obviously, today we have the Kubernetes and the Mesos of the world, which we'll talk about. So nobody is even thinking about it. But if you do, don't think about it. And suboptimal blue-green deployment. What is blue-green deployment? Blue-green deployment means you have a new version of the microservice, version 2. So version 1 is running like 5 services on 5 computers, and we want to raise them up. We can't push them all down and then push them all the new version up. Because if we push all of them down, boom, something will stop working. You have to do it gradually. You have to push one down, push a new version up, push another one down, push a new version up. That makes everything very, very slowly, very, very slow if you don't plan for it in advance. And the rollbacks were horrible. I mean, like 5-10 minutes. So if you find a bug in production, and yes, we do have bugs that happen only in production, then those 5-10 minutes are critical. The worst part for me is that the definitions of where a microservice is run on which server were static. So we had this map which says microservice A is running on this, this, and this machine, B is running on this machine, and C is running on this, this, and that machine. And that's very bad because developers started, have you heard about pets and cattle? Well, we started treating our servers like pets. We knew each one of them intimately. We knew how noisy our neighbors were, and we knew what problems we were going to have during the deployment. And that's not the way it works today. What we want to treat our servers is as cattle. I don't care about them. I just, want to put it on any server, and I don't care which. And something that people didn't talk about, but for me was problematic, is that on staging, where some of the software was tested, and on the developer machine, where our end-to-end test running, we had different infrastructures for deploying. So we had a deployment infrastructure for production, deployment infrastructure for staging, and we cobbled up something for our end-to-end tests, instead of having one deployment infrastructure for everything. So I asked myself, hey, I have 7 days. Can I rebuild it? Can I build a microservices infrastructure in 1 week? And I said, nah, no way, 7 days. And I have no idea what a microservices infrastructure is or how to build it. And then I said, hey, if God can build a whole universe in 7 days, I can build a microservices infrastructure. So I picked up a really, really, really good team of developers and DevOps people. Oh, not these. The head of infrastructure, head of server team, head of CI, my best friend, and myself. I convinced them, and they said, yeah, let's go, let's do it. And we did it. So we started talking. On the first day, we started talking, what exactly do we want to build? That was 2 years ago, almost. In like a year, this talk will be totally out of date. So we started thinking, what would be the scope of, we can't build everything for a microservices infrastructure. What do we want to build? And the scope was, we want to build a web service and an RPC service where the user gets the HTML page from the web service, just like any web app. And the web service communicates via RPC to the RPC service. And we wanted those services to be regular Wix services using the regular Wix Java framework. We have a Java framework, it's called the Wix framework, and we use it, and we wanted to keep using it. We did not want developers to change the way they develop, because we knew that if we did that, nobody would use it. And we wanted to do something like this. We had a brainstorm, and we had a brain thing. We said, one of the things that takes a lot of time, especially for us backend developers, is building a GUI for all this install and deploy and keeping it healthy and everything. So we won't build a GUI. We'll build a command line. And I love that idea, and I keep using it. If you have a GUI that you want for services, don't build it as a GUI. Build it as a command line. And the best thing is build it in Node. And just do npm install -g, G is global, and the name of your npm package, and it's installed. And it's there in the npm registry. Everybody can install it, one line, and it's installed. We called it Apollo because I don't remember. And we wanted to do something like this. Apollo, artifact deploy deploys the web service. That's the name of the web service, version 1.5, and please deploy 20 instances of that service. Where? I don't care. And if we do a curl, we should probably get the result. The web service was also called the RPC service, get back the result and get us back the HTML. And if we wanted to upgrade, the idea was just to do artifact deploy again, but with a new version. And it should do blue-green deployment and all that. And along the way, make it 30 instances. So that was a scope. And obviously, Wix being Wix, we wanted to have some marketing. So I contacted my nephew, and he said, yeah, sure, I'll build you something. And this is what we built. I'm particularly proud of the tagline, deploy like a boss, because it's built on Mesos. That's mine. So, which scheduler do we use? Today it's not called a scheduler. Back in the days it was called, today it's called an orchestrator. Okay? Which scheduler do we use? What is a scheduler? Well, this is a server farm. Well, nobody knows how a server farm looks today. It definitely doesn't look like this anymore. But let's say this is a server farm. And these are microservices instances. And we want to deploy these microservices instances into the server farm. This is what a scheduler does. We tell it, I need 20 A's, 10 B's, 15 C's, etc., and it deploys them on the servers. And it keeps them healthy. So if a server goes down, it moves the services to another place. And if a service goes down, it brings it back up again. Okay? It knows how to do that, given that we said that we need 20 A's, 10 B's, 15 C's, etc. Which scheduler? Well, we had lots of options. Mesos Marathon, Mesos Aurora, Nomad, and Kubernetes. These are the main ones on the market today. Which did we use? We chose Mesos Marathon. Do you know why we chose Mesos Marathon? I'll give you a very simple answer. Because we had no idea which one to use. I mean, we could do the whole column and table and pros and cons and all that shit. I can see fucking shit, I heard. But we didn't have time for that. And it was a pretty good choice. I think today I would use Kubernetes, but back in the day they were pretty similar. And one of the things we need in a microservices infrastructure, besides a scheduler, besides an orchestration, is service discovery. Do you know what film this is? You're kidding me. Reservoir Dogs. Oh no, this is Pulp Fiction, sorry, but most of it is Reservoir Dogs, yes. So this is the service, Mr. What was his name? Anyway. Wolf. Wolf? Yep, the wolf. Okay, so what is service discovery? Service discovery, there are three kinds that I think about. One is web service discovery. The browser goes to a certain path, wix.com/w/whatever, and we need to figure out which web service to go to, web service A, B, C, or D. The second one is RPC service discovery, or HTTP service discovery if you're using REST. It's a web service needs to RPC to the RPC service. It needs to know where it is and to get that RPC message across. And the third one is, I call it third-party service discovery. Where is the database? I need the address of the database so that I can connect to it. We decided that in this scope, we will not do third-party service discovery. But how to implement it? I mean, if it was Kubernetes, then it's already built in, but that's no fun. We wanted to implement it ourselves, and we didn't choose Kubernetes, and we didn't know that Kubernetes has web service discovery. So how? And let's talk about web service discovery. Web service discovery is always this way. The user does not go to a specific web service because it's all going to wix.com. So it goes to a load balancer, it goes to a gateway. And that gateway has a set of rules in the database which says /w path goes to web service A, /Z in the path goes to web service B. And it then routes it. The gateway is a reverse proxy, and it routes it to the correct place. So it's a reverse proxy. Which proxy should we use? HA proxy or Nginx? Those are the two main contenders for reverse proxies today. We chose Nginx. Why did we choose Nginx? Because. Well, actually, there is a reason. Wix extensively uses Nginx, so we said, yeah, well, why not? But we could have used HA proxy. I think HA proxy is more used today. But where do those rules reside? The /W goes to service A, /Z goes to service B. We said, yeah, why not in source control? We'll pull it from source control. And so we don't need a fancy GUI to define those rules. We just git pull, change, git push. And how does it know if it needs to go to service A, which host that service A is? Because service A can be in host 1, in host 2, and host 3. How does the gateway know to load balance between all those instances of the web service? And the answer is Marathon knows. Marathon deployed those web services, so it keeps track of which instances were deployed on which services and exposed on which ports. So the gateway asks the Marathon API, and we'll see that later, and knows how to load balance between the instances. What about RPC Service Discovery? What is RPC Service Discovery? A service A calls, we want to call service A or service B. Our RPC is like Java-based, so you just do a function call and it translates it into HTTP transparently. So that gateway needs to, again, reverse proxy to the right location. See the resemblance? Very, very similar. Same difference. So we said, okay, we'll also use Nginx. Where are the rules? Where does it know service A is this service, service B? And we said no rules, conventions. Our RPC infrastructure translates service A dot do something to /service A/. So we said we have a DNS entry rpc.int, and it goes to the gateway, and the gateway looks at the path, the first line of the path, and says, okay, go to service A, and it knows how to route, again, through Marathon. So let's recap. Our developer wants to deploy A and B. So she goes and writes in the command line Apollo deploy A and says 2 instances. This we sent to Marathon, and we'll see later how. Please create service A. I need 2 instances. And oh, this is the Docker image because we use Docker at Wix. Marathon will create 2 instances on servers, I don't care which. And now comes the user. The user goes to wix.com/apath. The web gateway looks at the rules, says, oh, I need to go to service A, queries Marathon for where service A is, and proxies the request to one of the instances. Again, RPC, A wants to call service B, goes through the RPC gateway. The RPC gateway queries Marathon, where are the Bs, picks one of the Bs, and there we have it. We have a full microservices infrastructure with service discovery. But we had to work on it. I mean, that was the plan. Now we had to deliver it. It took us about a day, a bit less. So we split the job. We were 5 people, 5 splitters, and one person did the system thing, Vagrant and Amazon. We decided we wanted to have the microservices infrastructure work locally on Vagrant and in the cloud on Amazon. One person wrote the sample web service and RPC service. One person, me, did the node thing and wrote the deployment code to Marathon. And 2 people worked on service discovery, RPC service discovery and web service discovery. Perfect split. Let's talk about the system. Vagrant and Amazon. The idea was we used Ansible, one Ansible script for both deployments, and the guy was an Ansible freak. He knew Ansible, so he did it like in one day. So the same Ansible script either installed Mesos, Marathon, Zookeeper, whatever was needed on your VirtualBox in Vagrant, or on Amazon on different hosts. What about the sample web services in Discovery? This is Scala code, not very important. Scala and Java are the same. But what you can see is when you build an RPC client service factory, you need to give it a URL. And that URL, we decided, will come from an environment variable that we will send so that the Java code is oblivious of what the base is. So hello service RPC client.say hello translates to this HTTP, and you can see RPC service inside as the first path. What about the deployment? How does artifact deploy work? It's actually pretty simple. Marathon is a REST API, so we just used an HTTP client. We did a put, and we gave it an app config. An app config is a JSON. This is most of the JSON. And we tell it, the ID is app ID, use this Docker image. And the Docker image comes from the service name and the version, which the user puts on the command line. The environment variable includes that environment variable that we saw earlier, the RPC int. We label it just to make sure. We do a health check. We give it CPUs and memories, and we say how many instances we want. Once we HTTP put that to Marathon, Marathon just goes ahead and does it very quickly. Marathon sees how many instances need to deploy, uses Mesos to deploy the correct number of them on the hosts, waits for them to be alive, and rests. The configuration is not one-off, so if one of the machines goes down, it redeploys on the other machines. It knows how to do this. We need to give it a static definition, and it knows how to keep track of that. That's beautiful. What about upgrading? Same. There's nothing there. It's the same app ID, so Mesos Marathon sees that the configuration has changed and starts doing its thing. And it sees that the Docker image has changed, so it does blue-green deployment. Let's say we have 10 instances, so it takes 3 instances, pulls them down, pulls back 3 instances from the new version, sees that everything's okay, and then does the rest like 3-3-3. Well, 3-3-4, or something like that. So it's all dealt with the Marathon. So we've did the first three tasks. What about the other 2? We did it in 3 days. What about the rest? Remind me never, ever in a hackathon to use systems people. I mean, our customers don't care whether it's a hackathon or not. When there's trouble, and we had trouble that week, so our systems and CI people didn't have the time, too much of a time. So we needed a change of plan, and this is from Reservoir Dogs, by the way. We said, yeah, let's do third-party service discovery and wait for them to finish the gateway. We didn't want to do it for them. What else? We said, hey, let's do staging, not only production. Let's do also staging. And how did we do staging? And this I'm very proud of. We decided that production is just another environment. And if we decide that it's a special environment, but it's just an environment with a name production. All the other, we can create as many environments as we want just by giving them a unique name. So we can create an environment env1, env2, env3. So we color our deployments with the environment name. And microservice in environment A will only speak with other microservices in that same environment. And we'll see how we did that. So they're deployed on the same hosts, but they don't see each other. They see only those instances from the same environment. How does it look in the CLI? Well, we added a new parameter, -e or -env, and we said minus E stage 1, and the default is production. Maybe it's not a good default for the real world, but hey, hackathon. And from the browser, we can't go to wix.com and go to a staging environment, so we said, well, the domain defines it. Stage1.wix.com is stage 1 environment, stage2.wix.com is another environment. And web service discovery, again, stage1.wix.com, etc. RPC services, again, stage1.rpc.in, stage2.rpc.in. And remember that RPC int variable? Now when we send that environment variable, it will be colored by the name of the environment we're deploying in. So the environment variable for a stage 1 instance will be stage1.rpc.in. And the environment for stage 2 will be stage2.rpc.in. But the code, the developer code, will stay the same. And we talked about third-party services. We did it, but I'm not going to talk about it in this talk. It all comes together. Oh, right. Glad there's speaker notes. While we were working on staging, the systems guys came through and started working on it. And remember, we had RPC Service Discovery and Web Service Discovery, and it was the same difference. But system people being system people, they decided to build it. One decided to build it using Node, and the other decided to using Bash. Systems people being systems people. Incredibly enough, both worked nicely. But they both used the same method. How did they do that? They had a service called the manager. The manager, every couple of seconds, remember, we labeled our microservices. So we labeled them with microservice true. We gave them a service name, and we also labeled them with the correct environment, the stage 1, stage 2, etc. So the manager goes to Marathon and says, give me all those instances. Tell me everything you know about these kinds of instances with these labels. And it goes to nginx.conf, and it changes the configuration file so that the reverse proxy will know how, it says if I'm on stage1.wix.com, go to this. If I'm on stage2.wix.com, go to this. And it knows about all the instances and everything. It generates a very, very big nginx.conf, and it restarts nginx. So the restart, nginx will reread the configuration file, and boom, and we have it. Why do we need to do it every couple of seconds? Why not do it on every deploy? The answer is health checks. What happens if a service goes down? Mesos Marathon will redeploy the instances somewhere else. So every few seconds, we need to check that nothing changed. This is very, very important. What languages I talked about? Bash is easier. I want to show you how to do it in Bash. Don't worry, you don't really need to understand Bash. I don't understand Bash. Oh, well. So again, this is the script that queries Marathon, reads the information, and generates the nginx.conf. So first of all, it goes through all the environments. And how does it know what the environments are? It queries Marathon for all the instances and does a unique to get the environments. You can see that unique over there. Goes through the environments, finds all the apps in that environment, and the app IDs, and then goes through all the app IDs and generates the part of the nginx.conf for that app ID. It says this app ID is this path and these instances, this host and this port, this host and this port, this host and this port. Please load balance this. This took us another 3 days. Okay? RPC, staging. Remember, we got it also working locally on our local machine. So we had both locally an environment working with the same deployment infrastructure, with the same command line. We had staging environments and production environments on the production hosts. And we did that in 6 days, which is amazing. I mean, if you think about it, 5 years, we're good, but we're not that good. If you think about it, 5 years ago, if you wanted to do this kind of project, it would never have taken you 7 days, maybe 3 months to half a year, because you would have had to home grow everything by hand. So let's recap how this works. Our developer says, I want to deploy A and B. This posts or puts a JSON configuration to Marathon, which says, I want these number of instances. I want this Docker image. I'm sending you the RPC environment based on the staging environment to s.rpc.int. We want the environment S, as you can see in the command line. And I'm sending environment variables for each of the third-party services. I didn't talk about that, but each third-party service will get the environment variable so that the service will know how to go to MySQL or to Kafka or to whatever service they want. We go to Marathon. Marathon creates those instances and keeps them healthy. That's important. Now that we have the gateways every couple of seconds, I think it was 10 seconds or something like that, goes and queries Marathon. What are the staging environments? What are the apps? And where are they hosted? And on what ports are they exposed on? Gets that information and generates an nginx.conf and restarts the server if that nginx.conf changed. Now comes the user. The user goes to wix.com/apath. The web gateway now is just nginx. It has all the rules on it for saying /apath is service A, and these are the hosts and the ports, so it reverse proxies and load balances to one of the instances of the A service. Let's say the A service does an RPC. How does it know where the RPC gateway is? It's getting it from the environment variable for that staging environment. RPC gateway is also nginx, so it knows based on the path to go to a specific service, in this case service B. This is the path /b/foo, so it goes to service B, and in that nginx.conf it says service B are these hosts and these ports, and it load balances them. And there we have it, a full microservices infrastructure built using Mesos Marathon and our own homegrown service discovery. An important thing to note is today's service, let's take Kubernetes. Kubernetes has built-in microservices service discovery. It doesn't need all that shenanigans we wrote. But it's interesting to understand that in the end, essence-wise, Kubernetes does exactly the same thing as we did, just in a more efficient manner. It does it in a very interesting manner today. But it does exactly the same thing. It has these gateways, and it reverse proxies and everything. And how does it know where those instances are? It queries the Kubernetes master or slaves or whatever. Exactly the same way. Okay, epilogue. We won the hackathon. I got a full day in a spa with my wife. People were absolutely amazed by, they saw the aging microservices infrastructure, and they saw us deploying in like 20 seconds, and they said, we want it. So did Wix build the microservices infrastructure? Of course not. There are other priorities, and that's fine. I mean, hopefully one day they will build it on better grounds than the job we hacked it in the hackathon. But it was really, really fun. And the end result, as I said, 6 days. Microservices, red-green deployment, blue-green deployment, third-party services, staging environments, built in 6 days. What about the 7th day? We rested. We're Jewish, aren't we? Thank you very much.
Okay, it was a really, really interesting presentation.
Thank you.
So I'm sure we have questions.
Yes.
So far.
Oh, sorry.
Why didn't use it in production? Let's say?
Because there's a big difference between hacking something and really building it for real production use, multi-data center, very robust, etc. I would guess about 3 to 4 months making this into a really serviceable thing, and Wix just didn't have the resources. I'll tell you why. It's the problem of good enough. Sometimes when you have something that is good enough, okay, then you don't go looking elsewhere because what you have is good enough. If it was a really bad infrastructure, what Wix has now, then fine. They would have taken it. But it's good enough. Gartner once said that for a technology to replace another technology, it doesn't have to be better. It has to be really better. And it wasn't good. It wasn't really better. Today, if they would have built it, they would have built it this way, obviously. But they didn't have the resources.